Hello everyone, I'm James Spencer. I'm with Team 54 for BYU Capstone. This is a general assembly video for a solar microgrid. Today we're going to be going over the whole system architecture, subsystem by subsystem, and explaining each piece and component and how they fit together and how you can assemble your own solar system wherever you may be. Part of the documentation that you will have received, in addition to the installation guide, maintenance guide, will be a compatibility document. This is where you will compile all of the specifications and information about your respective system to input to verify what type of cables you will need, how many panels to put in series versus parallel, what the rating of hybrid inverter you will need for the number of panels. We will attach a separate video going through an example of how to use this compatibility document, but keep it in mind when the compatibility document is mentioned throughout the assembly video, that is what we are referencing. The first subsystem of the whole architecture that we'll be going over are the solar panels, or they're known as PV arrays, which stands for photovoltaic. If you see solar panels or PV, they're synonymous. They mean the same thing. Next, we'll be going over the hybrid inverter system. This is what takes the photovoltaic array, stores the energy in the batteries, and then allows you to access it through whatever loads you plug in. Then we'll go over the batteries, how you need to connect them, how they play into the whole system. Then we will talk about the breakers and how you can use them to isolate specific subsystems when you need to repair them. Lastly, we'll be going over the loads and the load profile, how much power you have to use, and what you can connect to the whole system. Okay, the first subsystem we'll be talking about are the solar panels. When you are connecting your solar panels to the hybrid inverter, you need to take into account the maximum voltage and current that your hybrid inverter is rated for, and determine the output voltage and current of your solar panels. That will determine the manner in which you connect them. If we connect panels in series, like so, positive to negative, positive to negative, positive to negative, this will increase the voltage. If we connect the solar panels in parallel, positive to positive to positive, negative to negative to negative, this will increase the current. Your hybrid inverter has a maximum voltage and current that it can handle. For the compatibility document, you will need to find the specifications of the panels, and you will need to find the specifications of the hybrid inverter. And using those, you will be able to compute how many panels to put in series and how many to put in parallel. The next subsystem that we'll be discussing will be the batteries and how they connect to the hybrid inverter. Depending on the storage capacity that you are looking to have, you can have a variable amount of batteries. When connecting the batteries to the hybrid inverter, it is important to remember, much like the solar panels, the hybrid inverter has a maximum current and voltage for the batteries. This will help you determine how you need to connect the batteries, whether that be in series, like this, positive to negative, or whether that be in parallel, with all the positive nodes connected and all of the negative nodes connected. Due to the number of hybrid inverters available, we are not discussing specifics on how to connect to your specific hybrid inverter. That is up to you to determine the type of connector required and the type of series versus parallel arrangement that you will need to connect to the hybrid inverter to stay within the maximum voltage and current ratings of your system. The compatibility document will help you determine what specifications you need to get for your batteries and for your hybrid inverter to fulfill your system requirements. We will be discussing the hybrid inverter. The hybrid inverter is the heart of your solar microgrid. It takes the energy coming in from the solar panels, the PV array, it stores it in the batteries, and it controls how it is released to your loads. The hybrid inverter, the key things you need to keep in mind are its specifications and its ratings for current and voltage. The compatibility document will help you determine those. We will show you an example of a hybrid inverter later in this video and walk you through where you can find those specifications on your respective hybrid inverters. Now we're going to go over the breakers that you're including in the solar microgrid. The breakers are between each subsystem to prevent any one failure from damaging the rest of the system. They will limit the current and the voltage passing through, and if it exceeds the threshold for the breaker will trip, severing the connection from that subsystem to the rest. They're very important to include when you're dealing with higher voltages for safety reasons and for the protection of the system in general. Now I'm going to show you our hybrid inverter and how we connected it to the solar panels and the batteries. This isn't exactly how yours is going to be, but you'll be able to get a general sense of how you can find these same connections on your hybrid inverter. Here we have our hybrid inverter. How we found the specs for its maximum current and voltage are here on the side. So rated power, 1 kilowatt, 1,000 watts. Rated battery voltage, 12 volts. And then for the solar, the max solar voltage is 150 and the maximum current is 40 amps. So look for this kind of label on whatever solar inverter you use in order for you to know the specifications that you will put into the compatibility document. Now I'm going to go through and show you how we connected our batteries and solar panels to this hybrid inverter. This is to connect to AC power, to the wall power, the wall plug. We use this for testing purposes. You won't need this. These two lugs are how we connect our batteries. So here on the bottom it says battery. This is our PV in, so this is how we connect the solar panels. This is how we connect the battery. This is our AC in for the wall power. Our specific batteries are connected using these locking lugs. So we had to create a custom set of cables in order to connect the battery to our hybrid inverter. You have a video for making one of these cables in the documentation, there is a tutorial video on how to make the different cables. So we made these cables, one end to connect to the battery, one end to connect to the inverter, based on the size of this screw that was needed to connect it to the inverter. Finally, to connect the PV in, the photovoltaic cell, we created these MC4 cables. There's a video attached for you guys to make your own MC4 cables. And you unscrew this little locking bit to open it. If you see here, when you screw down, this little lock closes, and that's what holds the cable in place. So to open it, you turn to the left, you insert the cable for the solar panels, and then you screw to the right in order to lock it in, and you screw it as tight down as the specifications dictate, and then it's connected. So for our hybrid inverter, that's how you connect the batteries and the solar cells, but for yours it might be different. Make sure you look at the type of connection needed, and then according to those connections, find a corresponding video in the documentation we have provided. Here we have one of our solar panels. Yours will be different than this, but it should have a similar label as this one. This label gives you the specifications for this solar panel that you will plug into the compatibility document. For example, maximum power. So this is the maximum amount of power this solar panel can produce at peak sun conditions, 100 watts. The maximum output voltage is 22.68. The maximum output current is 4.41. So these are the numbers that you need to plug into the compatibility document so that you can determine the safe way to assemble your solar array with your hybrid inverter. Here is the back of the solar panel. These are the MC4 connectors that your panels will most likely have. If you look at the back, you can see a positive and a negative. These are the positive and negative nodes. These are the positive and negative ends on the solar panel. There is an attached video that shows you how you can connect these panels in series and parallel with this type of connector. So once you have put in the specifications into the compatibility document, when you have determined the number of panels you need in series and parallel to get the required power that you are looking for, go see that video to determine how to connect your panel array in series and parallel to fit your correct voltage and current of the hybrid inverter. So here is the battery that we've been using for our testing. It should have a label such as this that gives you the composition of the battery, what it's made of, what its specifications are. Ours is a lithium iron phosphate battery with this rated capacity, 150 amp hours, 12.8 volts, 120 amps of continuous charging current, 14.6 for charge current. There should also be a documentation packet that comes with the batteries that you get. Look through that to make sure everything is compatible. You will plug these numbers into the compatibility document to determine how many batteries you need to connect in series and parallel to fit within the standards of your hybrid inverter. Here we have the battery cell that we used for testing. As you can see, there are the two terminal ends, the negative terminal, the positive terminal. Using the specifications from the battery from the hybrid inverter plugged into the compatibility document, you will know how to connect your batteries in series and parallel using these two terminal connections. Please ensure that you are following all of the safety guidelines. As a rule of thumb, when you're dealing with high voltage and current, use one hand to connect everything to ensure that you don't complete the circuit by touching both ends and current passes through your heart in that way. So If you can, have a certified electrician install your system. If not, follow general high voltage safety precautions. This has been a brief overview of the subsystem architectures for your solar microgrid. Please read all the documentation that comes with each piece of equipment, follow all the safety guidelines that it suggests,